Okay, so I'm going to do an example of a related rates type problem, such as you might find on the AP Calculus exam. For those of you in my class, this is problem 17 from the assignment I gave you, and I've copied it here onto this document so that we don't have to flip back and forth. It says that water is flowing at a rate of 50 cubic meters per minute from a conical reservoir, vertex down, of base radius 45 meters and height 6 meters. And there are two questions that we're asked to find. The first is how fast the water level is falling when the water is 5 meters deep. The second is how fast is the radius of the water is changing at that moment. So the first thing we recognize is that in every related rates problem, really, the first thing that we should do is write down the rate that we're given and the rate or rates that we know. So in this case, the rate that we know is the rate of change of volume. Okay, now we need to be clear on this. This is the rate of change of volume of water. Sometimes students confuse this and start thinking about the volume of the cone. The volume of the cone is not changing. Okay, the height of the cone is not changing. The radius of the cone is not changing. Nothing about the cone itself is changing. So when we talk about 50 cubic meters per minute flowing from the conical reservoir, that's the rate at which the volume of water in the conical reservoir is changing. So dV dt is negative 50. And what we're asked for in this question is how fast is the water level, the radius changing. So what we're asked for is dr dt. Okay, we could very easily also be asked for dh dt. And although it's not asked for in the question, I'm going to solve it here anyway, because oftentimes in this kind of question, they would ask you for both. So the first thing we recognize is our formula. We're looking for a formula that connects V and R, or V and R and H, and that's a fairly well-known formula. The volume of a cone is 1/3 pi R squared H. We see that we have two variables here, and I mean, I could differentiate this. If I differentiated on the left side, I would get dV dt, and on the right side, I would get a bunch of stuff, but I would have dr dt's and dh dt's coming out. And since I'm not giving either of those, that's going to introduce a little bit of difficulty. Not insurmountable, but a better idea would be to see if we can connect R and H. And in this case, we can connect the R and H fairly easily using similar triangles. Okay, what we know is that the cone has this triangular shape, and the water inside the cone looks something like this. And we can see fairly easily that the blue triangle and the black triangle are similar. Okay, they each have a 90-degree angle. This angle down at the bottom is the same in both. And of course, if two angles are equal, three angles are equal. And so that tells me that we have similar triangles. I've already drawn a sketch of the cone, and I've labeled it, I think, correctly. Notice what I've done here is I've labeled this distance R because the radius of the water is changing. I've labeled this as 45. I haven't given this a variable name because it's not changing. It's just 45. Likewise, I've labeled this distance over here 6, the height of the cone, because it's not changing. So I don't give it a variable name. But here, the water level, the height of the water at the moment we're interested in is 5 meters, but that's changing as water flows out of the tank. So I've given this a variable name. I've called this H equals 5. So in my similar triangles, what I'm going to have here is inside the blue triangle, I got an H and an R. And outside, in the black triangle, I have a 6 and I have a 45. And that allows me to connect these up, and that's going to be very helpful. So I can say here that in this triangle, I'm going to say H is to R as 6 is to 45. And so now I can connect these up fairly easily, and I get H equals 6 over 45 R. 6 over 45 is the same as 2 over 15. So this is going to be 2R over 15. And that's the connection between height and radius. I could write it the other way just as well and say R equals 15 over 2 times H. So I've connected these variables. So what I can see here is once I get either dr dt or dh dt, Once I get either of these two, I can very easily get the other one simply by differentiating h equals 2r over 15 or r equals 15 over 2 times h. So now what I want to do is I want to take one of these and put it into my formula for volume, to simplify it, to turn it into an equation in one variable just because it's going to make it easier. So I think what I'll do is I'll take the 2r over 15 and I'm going to put that in for h. So I'm going to take this value and I'm going to think about putting it in to the equation right there. So my volume is now going to be 1/3 pi r squared. And now instead of times h, it's times 2r over 15. I'm okay with that. I could differentiate there, but it's always better to simplify before we differentiate. So if I clean this up, the 2/15 comes out in the front. This is now going to be 2 over 45 times pi. And of course, the r's combined, giving me an r cubed. From here, I can go ahead and take my derivative. So I'm going to get dv dt equals, this is just a power rule, so the 3 comes down, giving me, instead of 2 over 45, now I'm going to have 2 over 15. And this is going to be pi r squared times r prime. Okay, I see now that I've got everything that I need to solve for dr dt. dv dt, I remember, was minus 50. So this is minus 50 equals 2 over 15 pi. And remember my radius, well, actually, I don't know my radius yet, so let's go up and get that. I know here that r equals 15 over 2h, and I'm told that I want this one, h equals 5. And so what I'm going to do is I'm just going to take this expression here and solve for the radius when the height equals 5. So I'm going to say r, in this case, is 15 over 2 times 5, which is going to give me 75 over 2. Okay? So that can go in here. I now have 75 over 2 squared times dr dt. I want to solve for dr dt, so I'm just going to move this all over. I'm going to leave the numbers as they are because I think there's going to be a lot of good cancellation happening here. Maybe I'll do one step first. So let's call this negative 50 equals, and here what I'm going to get is 2 pi over 15, and then I'm going to have times 75 times 75 divided by 2 times 2, and that's times dr dt. And I write it like that because I can do some simplifying now. I can see that this 2 is going to take out that 2. I can say that 15 goes into that once, 15 will go into there 5 times. And so now I can clean it up and move it to the other side, and I think I can do even more simplifying. The 2 will come over, making this minus 100. Here I'm going to have 5 times 75 times pi in the denominator, and that will equal my dr dt. Again, I can clean this up. 25 goes into 100 4 times, 25 goes into 75 3 times, and so I'm going to be left with dr dt equals negative 4 over 15 pi. And the units here, well, I go back up to the question, and I see that this was all measured, I believe, in meters. Yeah, we're in meters. And so if my heights, my distances are measured in meters, my time is measured in minutes. So this is going to be in meters per minute, which is fine. I think the original question asked us for centimeters per minute. So we would have to multiply that by 100 to go from meters to centimeters. So I can say this is negative 400 over 15 pi centimeters per minute. And again, I can clean this up. A 5 will go into that 3 times. 5 will go into that 80 times. I think that's as good as that's going to get. So I'm left with negative 80 over 3 pi centimeters per minute. And that's the first part done. The question asked me for how fast the rate of the water is changing, so I've done that now. That's actually part B. Part A is asking for how fast the water level is falling, so that's my dH dt. But I have a formula right here that connects H and R. So I'm just going to take that formula and I can solve the second part very easily. I had H equals 2R, H equals 2R over 15. So if I take the derivative of that, I get dH dt equals 2/15 of dr dt. And since I've already solved for dr dt, I can just substitute straight in. So I've got 2/15 of the value that I got previously, which was negative 80 over 3 pi. Again, I can clean this up a bit. 5 goes into that 3 times. 5 goes into that 16 times. And so I'm going to be left with negative 32 over 9 pi. And that's going to be measured also in centimeters per minute. And that's all there is to this problem. Okay? Again, as I always say, I think the key to the whole thing is at the very beginning, writing down the rates that we know and the rates that we want to know, and then using the information given in the question and in the diagram to go forward from there. I hope this helps. Again, if you've got any questions, feel free to let me know.